Welcome to Study Loop.
For this problem, on the topic of waves and sound, we are told that a transverse wave is traveling on a string, and we are given the displacement y of the particle from its equilibrium position by the mathematical form of the equation. And we are also told that the linear density of the string is 1.6 times 10 to the minus 2 kg per meter. We want to calculate the tension in the string. So we know the general form of the equation is y is equal to a sine 2 pi f times t minus 2 pi x over lambda, where a is the amplitude of the wave, f the frequency, and lambda the wavelength. Now the equation for the displacement of the wave is given as y is equal to 0.021 meters times the sine of 25 times t minus 2 times x. So from the general equation, we can see, therefore, that 2 pi f times t is equal to 25 times t, which means that 2 pi times f is equal to 25. And so we get the frequency f to simply be 25 divided by 2 pi in hertz. We can also see that from the given displacement function, we have 2 pi x over lambda is simply equal to 2 times x, which means that 2 pi over lambda is equal to 2. And therefore, we can immediately find the wavelength of the wave lambda to be 2 pi over 2 in meters, which is simply pi meters. Now, we also know that the speed of the wave on a string, v, is equal to the square root of the tension in the string f divided by the mass per unit length in the string m over l. Or if we square both sides, v squared is equal to the tension F divided by the mass per unit length. Rearranging, we can solve for the tension as asked in the problem, and the tension F is equal to v squared multiplied by the mass per unit length. But if we substitute v for the frequency times the wavelength, we get the tension in the string is equal to v squared times m over l, which is the frequency times the wavelength all squared times the mass per unit length. Now we've calculated the frequency and the wavelength, and we're given the mass per unit length of the string, so we can find this tension. So this becomes the frequency, which we said was 25 divided by 2 pi, and that's hertz, multiplied by the wavelength, which is pi meters. We can see the pi's will cancel, and that's all squared times the mass per unit length of the string is 1.6 times 10 to the minus 2 kg per meter. And so calculating, we get the tension in the string to be 2.5 newtons.